Okay, so we're going to begin 6.6. This is our last section of the year. Hallelujah, right? And we're going to start by learning how to solve exponential functions. So this is when we have exponents in our powers. Okay. So first of all, just to be able to identify what type of function we have is very important. Okay. So if we have this one right here, this is just a cubic function. We're going to be able to factor it at some point, or just solve it by adding 4 into the cube function. This right here is just another polynomial. This is a polynomial. This right here is a linear function. This can be a line with the intercept of 5, slope of 1/2. This one is another polynomial. It's like a quadratic. Anytime the highest power is 2, it's just a quadratic function. It's a parabola. Okay. This is a logarithmic function. So anytime you see logs written out, it's a log function. We're going to need to exponentiate it. This is just another linear function. And here we have an exponential function. So anytime you see variables in our powers up here, in our exponents, that's an exponential function. Okay. And this one right here looks to be just another, probably again another polynomial, probably quadratic of some sort. Okay. And so just be able to identify what kind of function am I dealing with, right? So first of all, our first concept is if we have b is greater than 0 and b is not equal to 1, then b to the x equals b to the y if x is equal to y. So we've talked about this already. So if our bases are equal here, then we know that our exponents are equal. Okay, we know that. All right. So what is the solution? We've kind of done this already. So if we can kind of get our bases to be the same, then sometimes we can solve it that way. So we just go, it's going to be right the original equation here. So we just have 1/2 3x plus 7 equals 4 to the 3x. And then what we're going to do is we're going to rewrite each side with a common base. Okay, so I'm going to put this 2 up here to the -1, the x plus 7. And then I'm going to try to get this 2 to the base of 2. Let's see, the 4 to the base of 2. So this will be 2 squared, right? And that will be to the 3x power. And then we're going to simplify each of these, use our power property. So 2 to the negative, if I multiply these, it would be negative x minus 7. If we multiply those, right? Equals 2 to the, that would be 6x right here. Okay, so now since my bases are the same, I know that my exponents here will be equal to each other, right? So negative x minus 7 should equal 6x. And from this point, all I need to do is just start solving for x. Add x to each side, and we've kind of already done a little bit of this in a really small way. Now we're going to make it a little more complicated, okay? And so then from here, we're just going to continue to solve. And we end up with our x equals -1. And that's my value of x, okay? And so maybe you want to pause this video, maybe not, maybe you already know how to do this, see how you do, okay? So we have, this is the same thing as 1 over 1,000. So you can always write those decimals as fractions and vice versa. Don't be afraid of that, okay? Equals 10 to the 6x. 16, 10 to the 6x. Now, I know I have a base of 10 here, so I'm going to try to let's go ahead and put this 1,000 in the numerator by using that negative power to help us out. And then I'm going to write this as 10 cubed. 1,000 is 10 cubed to the -1 equals 10 to the 6x, which that will become 10 to the -3, right? Equals 10 to the 6x. Now I have the same bases, right? So therefore, I know that my two variables are, the two exponents are the same. Okay, so we know that -3 is equal to 6x, and all we have to do from here is divide by 6, so -1/2 equals my x, and there we go. Okay, and that's all nice and dandy, but we can't always do that all the time. It doesn't always work out. So here's another property that we have. If my log base b of x equals my log base b of y, so we have a log of the same base, and then x will equal y. Okay, so and vice versa. This is this. It says this if and only if. That means it goes the other way. So if x equals y, then the log base b of x is the log base b of y. Okay, so if two logarithms or exponents of the same base are equal, then the quantities are equal. So we can actually take the logarithms of both sides. So here we have 17 equals 4x, and 17 and 4 don't have the same base. We can't make them have the same base, right? And so what we need to do is we're going to take 17 equals 4 to the x power, And what we're going to do is we're going to take the log of both sides. So we're going to say log of 17 equals the log of 4x. Oops, log of 4x. Okay? So by doing that, we know that those two things are equal. So now what we can do is apply our log properties. So we can take this x and put it out here in front. So we're going to take our log of 17 equals x times log of 4. And so now we can actually operate with that x, right? So we're going to take this, divide by log of 4, divide by the log of 4, and so we're going to get the x is approximately equal to, and we have this log of 17 divided by log of 4. I have to come over here, I have to grab my calculator, so I don't have my calculator up right now. Shoot. Give me 2 seconds so I get my calculator up. So to find out what the log of 17 over the log of 4, I actually have it. It is about, no, I guess I don't have it here yet. Give me 2 seconds, I'll get this up. I had to shut my things down, so I'm sorry about that. Here it comes. So I have my calculator here. Drag it over to my other screen here. Okay, so I have my log right here. My log of 17. And close that, divided by my log of 4. And that's about 2.044. About 2.044. Okay. 2.044. Okay. And there you go. Okay, so we can solve it like that. Okay, so here's another one. So we write this one and solve. Okay. So right here we have 5 to the x power equals 12. We're going to do the same thing. We're going to take the logarithm of both sides. Log of 12. And because of that, we can swing this back in front. So we have x log of 5 equals log of 12. Okay, as a result, we can now divide by log of 5. And we get x is approximately equal to, and we can take that up here and say log of 12 divided by my log of 5. We got log of 5. Oops, I have 2 parentheses there. Log of 5. So that's going to be about 1.544. Okay? 1.544 for this guy. The value of x. Okay, so 5 to the 1.544 is what 12 is. Okay, so next up, these guys get a little trickier because now we have 2 variables on both sides. Now what? Okay, so let's look at this. So follow along closely. So log of 3, the x plus 1. So anytime you have variables in the exponents, we need to take the logarithm. Okay, as opposed to when you have a logarithm, we have to exponentiate it. So remember the inverse properties. Okay, so since it's in the exponent, we need to take the logarithm. Okay, it's log of x. That means we can now put these x's in front. So we have x plus 1. Remember to put it in parentheses because it's an entire package out here. Okay, log x plus 1 times log of 3 equals x times log of 5. Now what we need to do is distribute this log 3 through this parentheses. So it's x times log of 3 plus 1 times log, this number 1, times log of 3 equals x times log of 5. Okay. Now from here, what we have to do is you see that this has an x term with it, and this has the x term with it. We want to put those together so we can kind of get the x by itself. Okay. So I'm going to subtract this x log 5. Subtract this x log 5 over here. Okay. And I'm going to take this term to the other side. So I'm going to actually subtract this 1 log of 3 and move this to the other side. Okay, I'll do this all in one step if that's okay with all of things. And I know you're over there saying yes, I am. Okay, so I can't add these together. So this is going to be x log 3 minus x log 5. Oops, that's it. X log 5, there we go. Equals, and then we have over here my negative log of 3. Okay, but now what it allows me to do, since I have this x term here, and I can factor it out. So I factor out the x, and I'm left with this log 3 minus log 5 on the inside. Okay? So you have to get rid of these. Are kind of like, just you have to treat them like they're variable expressions, guys, okay? So don't get confused by them. So now all I can do is I can divide by this entire log of 3 minus log of 5. Just divide by the whole thing on both sides. Log of 3 minus log of 5. Okay, divide by the whole thing. Then I can find out what my x is equal to. I just put it in my calculator. Okay. Be careful how you put it in your calculator. So we're going to say negative, and the opposite of. Oops, not answer. Opposite of. There we go. Log of 3. Okay, divided. No, not minus. Divided by. You gotta know what you're doing with the calculator. And I gotta put parentheses because it's in the denominator. Okay, so log of 3 minus log of 5. And I have to close my parentheses again to make sure it's in the denominator. Okay. Now we have about 2.15. Okay, so that's what my x is equal to, about 2.15. And there's my value of x. Okay. Let's look at one more. All right, and make sure you guys can kind of get this down. So we have log 2 to the 3x equals log 7 to the x plus 1. All right, so now we can put those guys in the front. So we have 3x log 2 equals x plus 1 in parentheses of log 7. Okay, now remember we have to distribute this guy. Okay, so 3x log 2 equals x log 7 plus 1 log 7. So we're just going to write this log 7. Okay, so here we see this again. We have these two x's here. So I'm going to get these to be on the same side. Okay, so minus log 7 minus log x log 7. Okay, so now I have 3x log 2 minus x times log 7 equals log 7. Okay, and the same thing's going to happen. I'm going to factor out just the x. Okay, not the 3, leave the 3 alone. I'm just going to factor out this x. And I'm going to have this 3 log 2 minus log 7 equals log 7. Now guess what I'm going to do? Is I'm going to divide everything by that whole thing. 3 log 2 minus log 7. It's a lot of writing, right? 3 log 2 minus log 7. And let's get our calculator here and see what we evaluate here. Okay, so we have log 7 divided by, put it in parentheses because it's in the denominator, 3 log 2. If your calculator doesn't do this, you need to make sure you calculate both of them separately, numerator, denominator, and then divide, okay? Minus log 7, close my parentheses for my denominator, and I have about 14.57. Okay, so my x is approximately equal to 14.57. Okay, and that's how you solve for exponential functions when your variable is in your exponent, right? So you have an Excel, it's in Google Classroom 6.6 day 1, and I will see you all in class next. Please bring your questions. Have a great one. Bye-bye.